Hello everyone. In this video, we're going to continue our discussion about angle of elevation and depression. There's one problem that we will solve right now, which is this one. The ship is approaching to a cliff of a land. The length of the distance between the ship and the tip of the cliff is 70 kilometers. If the horizontal distance between them is 54 kilometers, then what will be the angle of elevation and angle of depression? Now, this is actually a tricky question. You know, take a look. This is a land, and yeah, there's a cliff, and there's a ship. All right. So horizontally speaking, their distance between them is 54 kilometers. And the distance between the ship and the tip of the cliff, right? The tip and the cliff is 70 kilometers. All right? 70 kilometers. Wait. I was wrong. We're going to put 54 kilometers here. There we go. That's it. 54 kilometers. All right? That's the horizontal distance. Now, our goal is to find the angle of elevation and angle of depression. Let's try that. Okay? Whereas angle of elevation is above the horizontal line, which is here. All right, it's here. Then angle of depression, which is below the horizontal line, but it seems like there's no horizontal line. So where should we put it? So we can imagine that there is another horizontal line here. Okay, this horizontal line above is parallel to the horizontal line here. So this is also 54 kilometers. All right. So here we can have an angle of depression. So angle of elevation and angle of depression. Right? Let's start first with the angle of elevation. Okay. So we have this one, the angle of elevation. Let's just say theta e, right? Theta e, so that we won't be confused. Right? So the hypotenuse here is 70 kilometers and the horizontal distance here is 54 kilometers. Now, what we're going to do is we're going to find the angle here. So I'm just going to go direct to the point because we have some practice earlier. Sorry, in the previous video. So here, we have a hypotenuse and we have an adjacent. So what trigonometric ratio we're going to use? So we're going to use cosine theta. Cosine theta is equal to adjacent all over hypotenuse. So let's substitute. Let's find that angle. Cosine theta e is equal to cosine theta sub e is equal to adjacent, which is 54 kilometers, all over the hypotenuse 70 kilometers. So put cosine there on the right side. We will have theta sub e is equal to arc cosine of 54 all over 70. Okay. So this is arc cosine of 54 all over 70. So here, you will have at two decimal places, it is 39.52 degrees. 39, wait, the handwriting's not good. So 39.52 degrees. So that's the angle of elevation. Now, how about for the angle of depression? So let me just write here. This is 39.52 degrees. Right? This is for the angle of elevation. Let me just erase this one. All right. So here, our goal now is to find angle of depression or angle of declination. So we're going to draw a right triangle for this one. We have the hypotenuse, we have its horizontal length. All right. So the hypotenuse here is this is theta d. Okay. Then we have a horizontal distance here, which is 54 kilometers. All right. Now we can imagine that there is actually a vertical side here. We can do that. And because of that, we can now have a right triangle. All right. So we have 70 kilometers. Now let's find this one. If you're ever having a hard time, just flip it. I just flip this one vertically. So this would be the result if you flip it vertically. So you have 54 kilometers. Then we have 70 kilometers. Then theta b. Okay, so what are we going to, what trigonometric ratio we're going to use? So here we have your hypotenuse and we have 54 kilometers as your adjacent. So we're going to use cosine theta. All right, so let's just substitute. Let's go direct to the point. So we have cosine theta sub d is equal to 54 kilometers all over 70 kilometers. Now, we will find the inverse of this one. So you will have theta is equal to arc cosine of 54 all over 70. And what would be the answer? At two decimal places, it is also 39.52 degrees. So this is 39.52 degrees. Now, if you're going to observe, angle of elevation here and angle of depression are the same. It may be not the same due to their locations, yes, but if you're going to take a look, their value, they are the same. Like numerically speaking, they are the same. So, can we conclude that angle of elevation is just the same as angle of depression? The answer is yes. Okay? Angle of elevation and angle of depression are congruent to each other, or in other words, they have the same measure. All right? Now, the question is, how are we going to know if they are congruent to each other? Think of it this way. We have a rectangle. Okay? This is a rectangle, right? Now, imagine there is one diagonal line where its endpoints are the vertices that are opposite to each other, or basically, we have a diagonal line that connects this point up to this point. If I have angle A and this one is angle B, if angle A is, let's just say 30 degrees, then angle B is also 30 degrees. If angle A is 60 degrees, then angle B is 60 degrees. So despite their positions, they're actually the same. This one is actually proven with the theorem in geometry, which is, I do believe it's PAIC theorem or PAIC theorem. P stands for parallel. Wait, my spelling's wrong. P stands for parallel. A stands for alternate. Let me write here. Alternate. I stands for interior. Then here we have uh, congruent. Apparent interior. Uh, yeah, congruent. I think. Wait, am I right? Congruent or congruent? Basically, fake theorem. Basically, uh, angles that are interior. Angles are interior here, but we have a parallel line here. And the parallel line is cut by a line which is transversal line. What we have here, that would be also the same thing as here. So if we have 60 degrees, we will also have 60 degrees here. So let's just say parallel interior angles are congruent. Okay, that's basically it. So I think this is congruence, not congruent, if I'm correct. But I think you get my point. My point here is that if we have a transversal line, then we have we have parallel lines here, two parallel lines. If I have 25 degrees here, then what I will have here is also 25 degrees. That's the same thing here for the rectangle. Okay, if you're going to take a look again, all right, wait. If you're going to take a look again, if I have an angle here of 30 degrees, that will be also 30 degrees. Okay, so let's relate it here in angle of elevation and depression. Suppose this is you, and let's try the, I mean, let's relate it to our previous example in our first video about angle of elevation and depression. Right? There is a clock and there's a box. Right? And this is your horizontal view. Okay? So if you're going to look up just to see a clock, you will form an angle of elevation. It could be the tilting of your eyes or the tilting of your head. Now, if you're going to look at the angle of depression to, like to the clock, to the clock, then you can have a horizontal line here, which is parallel to your horizontal view of sight, and this would be your angle of depression. That's it. Okay? Now, earlier, or sorry, previously, we also try to tilt our eyes or head just to look at the box, right? So you have an angle of depression here because it's below the horizontal line. But what if uh angle of elevation to the box, okay, to the box. So here you can imagine having a horizontal line here, then you will have, sorry, you will have an angle of elevation. That's it. Okay? It depends, okay? It depends on the points, okay? Just because we have an we knew that angle of elevation and depression are congruent to each other, that doesn't mean they are equal to each other. It actually depends, all right? So for example, for this case, a person looks at the clock, okay? So here, the our uh, our face is tilted upwards just to see the clock. And that distance between the horizontal line and that viewpoint that you see at the clock is your angle of elevation. Wait, why is it A? This is actually E. So that's your angle of elevation. Okay, this is E. Alright? But what if, okay, okay, the same thing, you tilt upward just to look at the clock, but angle of depression. So here you're going to draw an imaginary line, then you have an angle of depression here. Okay? The same thing here. Okay? I mean, similarly here, you tilt your face just to look at the box. So horizontal going down. So you form an angle of depression here. Okay, here. That's the angle of depression. But what if you want angle of elevation? So imagine there's a horizontal line here and there's an angle of elevation here, which is above the horizontal line. So there, what will be the angle here? It's just the same the angle here. Likewise, what will be the angle here? That will be the same as the angle here. Okay? So I think you get my point. Here, okay, if you're asking me, are these two the same? No. No. I mean, in some cases, yeah, but it depends, right? It depends. Okay? So, if you're asking me if they're always the same, no. But if you're asking me if this angle of elevation is the same as this one, yes. Angle of depression is the same as this one. Angle of elevation here, yes. But these two, the same? No. It depends on a certain situation. So now you know. Okay? Now you know that angle of elevation and and the pressure are congruent to each other. That means they have the same measure. All right? But again, it depends on the viewpoint or the point. Okay? And that will be all. That would be the discussion for the angle of elevation and depression. Don't worry, we will have some practice videos about this one. Okay? And oh, okay. Anyway, so yeah, that will be our discussion for this one. All right? So see you soon.